Welcome everyone to today's video on diagnosing P-Series indoor units. So let's talk, Scott, a little bit about the difference between P-Series indoor units and M-Series indoor units.
Okay.
So P-Series indoor units, the fan rotation acts a little bit differently, right? So diagnosing a P-Series is much different than an M-Series as far as the procedure. If you're diagnosing a indoor fan motor rotational feedback on an M-Series, you're going to want to look that up in the service manual and follow the troubleshooting flow chart.
Okay.
With P-Series, a little bit easier. And as instructors, we've kind of broken this down and through a lot of testing in our training rooms, that the best way to diagnose a rotational feedback error code is with the system off. All right, so first, contractors out in the field, they're going to get a fan rotation error code. Number one, and I break this down into 3 steps. First step is they want to clear that error code. And the reason we clear the error code is because the error code can actually cause voltage readings to be bogus. And what I mean by that is some of the voltages that you're going to be reading could be skewed by that error code.
And so what would be the best practice to clear an error code?
Reset the disconnect,
okay.
Right? And everybody asks, how long do you reset a disconnect for? Basically, we're shutting the power off to that outdoor unit and we're waiting for all the lights to go out. On P-Series, it can be a little bit more tricky. P-Series like to retain their memory. Yes. So this may take up 10 to 15 minutes sometimes to get rid of that error code. But once that error code is cleared, now we want to do step 2, shut the system off. And when I mean shut it off, don't disconnect power. We're leaving the power on, we're just shutting the mode
Which
off.
you can do right on a controller.
Right on a controller,
okay.
Handheld remote, wall controller, whatever it is. Just shut that system, put it to off mode.
Okay.
All right, and we're going to do our diagnosing from there. Step 3, and here's the real important one, needle leads. Right, so we want some needle leads on our meter. Stock leads, especially on wall-mounted units, the motor plugs are really small. Okay. So large, clumpy leads are going to kind of damage that connector. And if you're on a phone with tech support, you're calling Atlanta, you may not be getting that lead all the way into that pin and getting an actual reading.
And you get a false reading.
Yes, and that TSA, that tech support guy is going to lose faith in you real quick because he doesn't know if you're actually
I can see that happening, yes.
Getting a reading, right? Yes. So now you got needle leads, now we're ready to go. Now today we're working on an SVZ. We would all love to work on SVZs all the time because they're easy to access, right? Our motor connector is right here and it's a big connector. So we could actually use larger leads, but in this case we have our needle leads today. So again, we have to rule out what caused this rotational feedback. Basically, the system does not see, or the indoor board does not see a rotational feedback voltage coming back to it. That's what throws the error code. Okay. So where are we going to start? We got to rule out the most obvious. Right.
Blower wheel? I mean, is that
seized?
Seized. Okay.
Right. The motor is seized. Did it blow a fuse on the board? Right. We got to look at these basic things and rule them out. Is the motor caked with dirt? Is it completely covered in dirt?
Hitting the housing or something?
It's hitting the housing. Maybe somebody took the blow wheel out for maintenance. They put it back, but they didn't tighten the set screw, and now it's shifted over, and now it's locked up and it can't spin. Now we've ruled all that out. So now we have to figure out one of 2 things. Is it the motor, or is it the indoor board? Okay. Now, we get a ton of boards back to the factory every year that have nothing wrong with them. We get a lot of motors back to the factory every year with nothing wrong with them. And it's common practice for a lot of technicians out in the field to change both.
They change out both.
Now, why are they changing both? They're not going through all of this work, right? Exactly. And they don't want to come back to that customer's house for a second or third time to replace a component because it was misdiagnosed. Okay. Is it possible for both the motor and the indoor board to be malfunctioned or be defective? Yes, absolutely. But we can do some checks and see if that rotational feedback is actually reaching the board. Okay. So if the motor is putting out rotational feedback and the system is still throwing a rotational feedback error code, the indoor board may not be interpreting the rotational feedback. So in that case, we're replacing the board. right?
Okay.
So now if the motor is not putting a rotational feedback out of it, and we're going to talk about these voltages in a minute, then the motor is defective.
Yeah.
And the indoor board is good,
Because
right? We're assuming.
Yeah, because the indoor board's not getting that signal back to the board.
Exactly, right? So every time that motor makes one revolution, it sends 15 volts to the indoor board. Here's the trick though, because this happens so fast as the motor is spinning, we don't have a multimeter fast enough to read that rotational feedback when it's running.
Every full turn sends it, but
Yes.
if it's running,
If it's
not gonna
running, what
catch
you're
that.
normally going to see is half of 15 volts, which is 7.5 constant.
Constant, okay.
That doesn't tell us if it's defective. That doesn't tell us if we're getting a pulsing voltage. So this is the reason we're doing it with the system off.
Okay.
So right now we're going to look at our pins on our connector, and basically we have a common. And in this case, it's our blue wire or pin number 4. And between common and pin number 1, we have a space there. And they purposely leave a space in that connector for prevention of arcing. So we all know that DC voltage has
Loves
a
to
characteristic. It likes to jump, it likes to arc.
Yes.
Right? So between pin 1 and 4, there is a space there. That's our 300 volt feed to the motor. So between common and 1, we should read 300 volts. So let's do that, Scott. And we're going to go between 1 and 4. Right, and right now we have 299.4 volts, so we're good, right? And that 300 volts, we're just looking at a ballpark of 300 volts. And that 300 volts in the system is based upon incoming AC voltage, right? So if you have a lower AC voltage incoming, you may have a lower DC voltage, but we're in the ballpark of 300 volts. Now let's look at now again, I said our common pin is our number 4, or blue wire. Now we're gonna go from 4 to pin number 5.
Okay.
Pin number 5 is going to be our constant 15 volts to the motor. And that's going to play a role in our rotational feedback. So right now we have 14.73.
We're good.
We're good. We got that constant 15 volts.
All right.
Now we're just going to leave 1 meter lead on the common, and we're just going to hopscotch to the other pins. And we're going to pin number 6 now. This is our speed signal to the motor from 0 to 6.5 volts DC. Right? So right now our system's off.
So
we're seeing 0.
Exactly.
Right? But if it was running on low speed, we could see a couple of volts, maybe 1 volt. Medium speed, maybe.
But this also be a good check if you want to know between your low, medium, and high speed, and this will detect that.
Exactly. So if we went to a controller on the wall and adjusted the fan speed, that voltage would change. Right? Here's the critical one, the last one, and Scott's just going to jump from pin 4 to pin 7. That's our rotational feedback, and that's what throws the error code. Now, right now, I'm reading 14.7 volts, and that's at 15 volts. So how am I going to see pulsing rotational feedback 0 or 15 volts coming back? Because that's what we're looking for, 0 or 15 volts pulsing. Well, we can spin the blower wheel by hand.
Yes.
So I'm just going to turn the blower wheel, and again, make sure your system's off before you stick your hand in there. But we're going to spin that squirrel cage blower, and you can see on the meter that it is pulsing from 0 to 15 volts.
Correct.
And we want to just spin that blower wheel very slowly,
Slow.
right? And just turn it gently, and there's our rotational feedback. That tells me this system is functioning properly. We have that rotational feedback. In this case, if this system was in error, which it isn't, if it did have a rotational feedback error code, and we had rotational feedback coming out of the motor, what's bad?
We have rotation coming out of the motor, then the board will be bad.
The board would be bad, exactly. So that's how we diagnose P-series indoor units. Again, M-series indoor units, wall mount, floor mount, one-way cassette. You're going to want to go to your service manual. It's a little tricky, but there's a flow chart that guides you through there on how to do that. And we'll have another video on how to diagnose M-series indoor units in the very future. So that about covers
Yeah,
it.
that
Scott.
does. Thank you.
Thank you for joining us. We'll see you on the next video.